Okay, so our notes for today are going to be on linear functions in slope-intercept form. Our content objective is going to be to graph linear equations and write equations of lines. So we will actually do another day of this when we talk about different equations of lines, but today we're focusing on slope-intercept form specifically. Our language objective is going to be to use key terms like slope, linear equation, y-intercept, x-intercept, slope-intercept form, or when talking about linear functions. So let's jump right in and talk first and foremost about slope, which is going to be a super key term for today. So the definition of slope for a line is the ratio of the vertical change to the corresponding horizontal change. So you have probably worked with slope before, but just so we have a visual of what I'm talking about, let's draw a quick little graph. So we have our x and y axes and our origin, which I'm labeling O over there, and say this were our line. So this is our linear function right there. The vertical change is going to be, I'm going to draw it in orange real quick, is going to be, if you choose a point, actually let me choose my point. If I choose these 2 points here on my line, the slope is going to be the vertical change, which is in orange, over the horizontal change, which is purple. So we'll label these. This is our vertical change, and this is our horizontal change. And our slope is going to be this vertical change over that horizontal change, or the rise over run. Or if I labeled these points x1, y1, and x2, y2, so in coordinate point form, I know that it would be the change in y, so y2 minus y1 over the change in x's, so x2 minus x1. So that's going to be the next definition, or part of the definition that I write down. So slope, which is typically defined or used, m is typically used as the variable for slope, is going to be the vertical change or the rise over the horizontal change or the run, which again translates into y2 minus y1 over x2 minus x1. So the change in the y's over the change in the x's, and that is our slope. One small detail, this only works where x2 minus x1 does not equal 0. So again, you can never divide by 0. I'm sure you've heard that before, but you can never divide by 0. You can't split something 0 ways. That doesn't make sense. So if that equals 0, then you'd have an undefined slope. It doesn't work out. All right, so let's do a quick example of this, of finding slope. Let's find the slope that passes through the points -3, 7 and -2, 4. So we're going to find the slope that passes through those 2 points. So this is my formula for slope if you are looking for a formula, but really I'm hoping you're remembering conceptually it's just the y subtracted over the x's subtracted. The thing you have to be careful of is that you're consistent in this, so let's just do the example. So I'm going to put this in parentheses, so if this is helpful, if you realize you are losing track of which x's go with which y's, I'm going to have you label the points. So I'm going to rewrite them -3, 7, and -2, 4. So I'm going to call this x1, y1. This is x2, y2. And then I'm going to substitute into my slope formula. So m is equal to y2, which I said is 4, minus y1, which is 7, over x2, which is -2, minus x1, which is -3. So I end up with 4 minus 7 over -2 minus -3, which simplifies to -3 over -2 plus 3, which simplifies to -3 over 1. Or, I know -3 divided by 1 is just -3. So I can simplify that way. So simplify. And my slope is just going to be m equals -3. So that's how we can use our slope formula. Again, it's just y2 minus y1, x2 minus x1. The important thing here is to note that these should correspond and these should correspond. So basically, if you're writing this point first, the y should be over the x for this point, and the y should be over the x for this point. So notice 7 and 3 have to go on top of each other, as 4 and -2 do. And the y's go on the top, x's go on the bottom. All right, so the last thing I'm going to do with this before we move on is interpret what this means. So if we have a slope of -3, what is that actually telling us? And this tells us that the line goes down 3 units for every 1 it goes to the right. For every 1 unit it goes to the right. So to visually see what this means, I'm not going to draw a full graph, but basically I would go down 3 and over 1. So I'm doing a little visual here. I would have a slope that looks, generally like that. So it goes down 1, 2, 3 units over 1, and then the slope would look something like that. So pretty vertical and going in the negative direction. So make sure you have that down. I'm going to move on and show us a couple little quick sheet or things to remember about slope. So we'll do a quick little table showing positive slope, negative slope, zero slope, and undefined slope. So I'm going to do some quick little drawings to show us what those generally look like. So we're going to draw them on graphs. So I'm drawing these. Okay, so these are all of our x and y axes. And a positive slope is going to be x is going to, as x gets greater, y will also get greater. So our positive slopes will generally look like that. They're going, as x gets positive, y gets positive. Our negative slopes will be the opposite. So as x gets positive, y is actually getting negative. So as x goes in the positive direction, our y is going in the negative direction. Our zero slope means that our change in y is 0. So the y's aren't changing, so it's just going flat. It's a flat line. Again, these are general, they're not any specific slope. So our zero slope is just a flat line. Our undefined slope would mean that x is 0. So it would be a vertical line. So our x's aren't changing, so it would just be a vertical line. And that is, again, why it's undefined, because we'd have 0 in the denominator of our slope, which doesn't work, so it's undefined. So those are the 4 types of slopes you might see. So now I want to talk more specifically about slope-intercept form. So slope-intercept form is the equation of a line written in the form y equals mx plus b. This is probably the equation you're most familiar with, or you're most comfortable seeing linear equations written in. And this is where m is the slope and 0b as a coordinate point is the y-intercept. So that's our definition of slope-intercept form. Y equals mx plus b, m is our slope, B is our y-intercept, or 0b is the coordinate point for the y-intercept. So we're going to do an example of this really quickly. For example, using this. So I want us to figure out what is the equation of the line with a slope of 1/5 or 1/5 and a y-intercept. I'm going to abbreviate it y-int dot of 0, -3. So first thing we're going to do here, rewrite our slope-intercept form so we remember what it looks like, and then I'm going to substitute those values in. So I have y equals 1/5 x plus -3. So I'm plugging in the 1/5 for the slope and the -3 for the b, or the y-intercept, and then I'm going to simplify. So I get y equals 1/5 x minus 3, and that is my my slope-intercept form for that linear equation. Now, last thing I want us to do together before we're done these notes is a second example that gets a little bit trickier. So example 2, I want us to write the equation in slope-intercept form. And determine the slope and y-intercept. Again, I'm abbreviating y-intercept as y-int. So we're going to start with 5x minus 4y equals 16. So this is where all of our skills from last unit come into play, because I'm going to rewrite or move some numbers and variables around to get this into the form that I want, which is y equals mx plus b. So what I'm ultimately trying to do, step 1, is to isolate y. So if you notice, y is all by itself, or it's all alone on the side in slope-intercept form. So what I want to do with this equation is get y alone. So I'm going to do that by first subtracting 5x from both sides. So minus 5x minus 5x. And I get -4y, -4y is equal to -5x plus 16. Notice that I'm putting the -5x first, because if I look at slope-intercept form, the mx comes before the b. So just to keep consistent form, I want to put my constant with x, or my coefficient x and its coefficient, in the front of that side of the equation. The next thing I need to do to isolate y, or get y alone, is divide both sides by -4. So I'm going to divide by -4. And when I say both sides, I can either divide that whole side by -4, but since these two pieces are separate, I'm going to divide each part by -4. So I'm going to make a note of that here, each part, because if I put this all over -4, that would also be right, but it would not give us the form that we're looking for, y equals mx plus b. So when I divide by -4, -4 divided by -4 is 1, so I'm left with just y. -5 divided by -4, the negative divided by a negative cancels out, and I'm left with 5/4x. And again, I'm writing that as a fraction so that I can keep my form consistent. And then 16 divided by -4 is actually going to be -4. So I simplify. That was my next step. And then the next step after that, since it asked me to determine the slope and y-intercept from this form, I'm going to compare it to my original equation to identify, so y equals mx plus b, to identify which part corresponds with which. So m must be equal to 5/4, since it is the coefficient of x. B, or the y-intercept, must be 0, -4, because the -4 goes in for the y value in the y-intercept. So my y-intercept is 0, -4. So there's my slope-intercept form, there's my slope and y-intercept, and I'm done that problem. All right, make sure you write down any questions, comments, concerns you have so we can go over them together in class.